We're going to assign the R and the S configuration, which is also called the absolute configuration in here. But before we actually start, I want you to notice that the hydrogen, it's not in the back in neither one of these ones right here. So I am going to practice with you the rotation of the molecule. Before we rotate, let's just go ahead and assign priorities to the groups that I have attached to my chiral carbon. You have to go one by one. I have a nitrogen, a carbon on the left, and a hydrogen in the front. Just by atomic number, nitrogen has higher atomic number, so it automatically gets number 1. I have carbons, 2 carbons right here that have the same atomic number, so I move on to the next atom they have attached to them. This one has an oxygen. This one doesn't have any more atoms attached to it. So the carbon that has the oxygen gets number 2, the methyl gets number 3, and the hydrogen gets number 4. Now, Kleiningold and Prelog, the system that they had, they want to put number 4, whatever that may be, in the back. And to actually make sure that we know how to do this, we're going to rotate, but we're going to hold on one of the groups in place so that we don't lose track of what we're doing. I'm going to hold on the CH2OH in place, and notice that what I have just done is just I took off the labels. I still have the wedges and the dashes pointing in the exact same direction, and what I want to do is that rotate this 3 as if you were twirling an umbrella. You're going to rotate this 3 right here until the hydrogen goes to the back. When the hydrogen goes to the back, this nitrogen right here goes to the very top, and the methyl comes all the way to the front. So we're just rotating this 3 to the left. Once you do that, you go ahead and transfer your priorities. And we start at 1, go to 2, go to 3, and back to 1. So 1, 2, 3, 1, 2, 3. We're going counterclockwise, and this one right here is the S enantiomer. Let's do it one more time. This time around, my hydrogen is all the way to the bottom. Whenever I actually rotate, you can hold on either to the aldehyde that's on the left, or you can hold on to the one in the front, the CH2OH. I don't hold on to the hydrogen or the dashes because I want the hydrogen to go to the dashes. So let's go ahead, and just to keep it interesting, let's hold on to this CH2OH. All I'm going to do is rotate the other 3. I'm going to rotate them. If you want to rotate them clockwise or counterclockwise, I want this hydrogen to come to the back. So that's where I want my hydrogen to be. The CH3 is going to move to the left, so it's going to be over here. And my aldehyde is going to come to the bottom. I'm ready to assign priorities here, and I go carbon by carbon or atom by atom until I find a difference. Carbon, 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 they're all the same. I move on to see what else is attached to them. This carbon right here is single bonded to an oxygen. This carbon is double bonded to an oxygen. So if you were to actually use the parentheses method, this carbon right here is attached to an oxygen and to 2 hydrogens. This carbon of the aldehyde, since it's double bonded to an oxygen, we're going to put 2 oxygens in here, to 2 bonds to 2 oxygens, and it also has a hydrogen. And then you compare what you have in parentheses. Oxygen, oxygen, same atomic number. Move on to the next. Oxygen, hydrogen, oxygen here is more important. So the aldehyde is going to get number 1. This one is going to get number 2. And this one is going to get number 3. So start at 1, go to 2, go to 3, And again, we are going counterclockwise, so this is the S, enantiomer.